Hi everyone, so this is the last video in the lesson and it's all about solving rational equations. And like we've discussed before, rational equations is just a fancy word for a fraction, and so to solve rational equations, it's the same thing as solving an equation with fractions. But I'm going to show you a couple of tricks to make it a little bit easier through the process. So the first step in this is to get common denominators, because in order to add and subtract fractions, we need them to have those common denominators. So let's start with this first example, which is 1 over 4x minus 1 over 4 is equal to 1 over 2. In order to have those common denominators, we need to find something that they could all multiply to. Now, that 4x in the front looks like it's the most complicated, and so we're going to leave that there and see if we can get the other two to be 4x, which, to make this middle fraction 4x, I would just have to multiply by x, right? Because 4 times x is 4x. And then to get the last fraction to be 4x, I would multiply by 2x, because 2 times 2 is 4, and then times x would be 4x. So that's what we're going to do. We're going to multiply the middle fraction by x and the last fraction by 2x. But remember, in order to get them to be common, what we do to the top has to be the same as what we do to the bottom. And so if I'm going to multiply the bottom by x or by 2x, I also have to multiply the top by 2x. So I'm going to multiply this guy by x on top and on bottom, and then this guy by 2x on top and on bottom. All right, so with that said, we would leave the first fraction the same, 1 over 4x, because we didn't do anything to that, and then it's going to be minus 1 times x on the top will just give me x, or I can write it as 1x, over 4 times x, 4x, equals 1 times 2x would just give me 2x, because 1 times anything is itself, and then 2 times 2x would give me 4x. All right, cool. So now we have common denominators. The next step could potentially be that we can combine like terms and then solve, because they all have common denominators, but this is my trick that I wanted to show you. When I have common denominators all throughout and there's an equal sign, like I'm solving an equation like this, I can actually just cancel out all of the bottoms, because they'll cancel themselves out anyway. And so now I'm just left with 1 minus 1x equals 2x. And I can solve that. That becomes a little bit easier because now you're not dealing with a fraction. So to solve this equation, what we're going to do is add 1x to each side, because what I do to one side, I do to the other side. I'm left with 1 on this side because the 1x's cancel out, equal 2x plus 1x gives me 3x. And then I can divide each side by 3 to get x is equal to 1/3. All right. And that's my answer. X is equal to 1/3. Perfect. All right, let's go through the next example. So the next example is 1 minus 2 over x squared is equal to 1 over x. Once again, we want them to have common denominators. Once they all have common denominators, then we can cancel them out. The first thing I'm going to do, though, is get this 1 to be a fraction by just putting it over 1. So 1 over 1. Now we have to decide what the common denominator could be. I'm going to look for the most complicated bottom already there, which is x squared. And so I want to see if I can make the other ones x squared. To make the first one x squared, because it's just a 1 on the bottom, I just multiply by x squared. And then to make the last one an x squared, I can just multiply by x, because x times x is x squared. But once again, what you do to the bottom, you have to do to the top. So I'm going to multiply the top of this guy by x squared, the bottom of this guy by x squared. Same thing over here, I'm going to multiply by x on top, x on bottom. All right, then what would we get? So we'd get 1 times x squared is x squared over 1 times x squared is x squared minus 2 over x squared is equal to 1 times x, which is just x, we could have left it as 1x, over x times x is x squared. Now that I have all of the bottoms the same, I can cancel them out. And I'm just left with x squared minus 2 is equal to x. Now, notice you have an x squared and an x still. When you have this and you're trying to solve, the first thing I want you to do is get it set equal to 0. So I'm going to move this x over here. So it becomes x squared minus x minus 2 is equal to 0. Once I have that, that is a quadratic trinomial, so we can solve it a couple of different ways. We could graph it potentially and see where it crosses the x-axis. We could use the quadratic equation. We could factor it. I'm going to factor it because I believe this will be pretty easy to factor. So here's our box. We're going to do x squared up here, negative 2 down here. We want to find two numbers that multiply to be negative 2 and add to be negative 1. So we know 2 is just 2 times 1. Like, that's the only factor of 2. So to add it to be negative 1, we would make the 2 a negative, because negative 2 times 1 gives us a negative 2, and a negative 2 plus 1 gives us a negative 1. So we'd have a negative 2x in one box and a 1x in the other box. The bottom two boxes have a 1 in common. The top two boxes have an x. The left two boxes have an x, and then the right two boxes have a negative 2, which means my factors are x minus 2 and x plus 1. Once I have it in factored form, I can set each chunk equal to 0 and solve. So x minus 2 is equal to 0, x plus 1 is equal to 0. I'm running out of space here, but you would end up with x is equal to 2 right here if I added the 2's, and then x is equal to negative 1. And those are my two answers. I get two answers in this case, and that's totally fine to get multiple answers because either of them will work. All right, let's look at the third example. On the third example, we have 1 over x minus 4 plus 4x plus 20 over x squared minus 6x plus 8 is equal to 3x minus 9 over x squared minus 6x plus 8. So once again, we want them to have common denominators, but the first thing I'm going to do actually on this one is factor the x squared minus 6x plus 8, because I have a sneaking suspicion that one of the factors will be x minus 4, which will make our jobs a little bit easier. So if I'm going to factor out, let's do the box method for the x squared minus 6x plus 8. So it has to multiply to be positive 8 and add to be negative 6. So 8 is 1 times 8 or 2 times 4. The 2 and the 4 will work as long as both of them are negative, because negative 2 times negative 4 gives you a positive 8, and a negative 2 plus a negative 4 gives you a negative 6. So I'm going to put negative 4x in one box, negative 2x in another box. Then let's factor. What do the bottom two boxes have in common? A negative 2. What do the top two boxes have in common? An x. Left two boxes have an x in common. Right two boxes have a negative 4. So your factors for that are x minus 2, x minus 4. So I'm going to rewrite it down here so that it's 1 over x minus 4 plus 4x plus 20 over x minus 2, x minus 4 equals 3x minus 9 over x minus 2, x minus 4. Okay, and I was right. My suspicion was right that one of the factors is x minus 4, which makes our jobs easier because now, instead of multiplying that first fraction by x squared minus 6x plus 8, all I have to do is multiply it by x minus 2 because that's all that it's missing. It already has the x minus 4. So I'm going to multiply the top and the bottom by x minus 2. And we would end up with 1 times x minus 2 is just x minus 2 over x minus 4, x minus 2 plus 4x plus 20, x minus 2, x minus 4 equals 3x plus, or I'm sorry, not plus, minus 9 over x minus 2, x minus 4. Okay, now they have the same denominators, which means I can cancel them all out. And we're left with x minus 2 plus 4x plus 20 equals 3x minus 9. Let's combine like terms on the left. In fact, one second. Let me move this guy just so we have some more space. Okay. Here we go. So now let's combine like terms on the left side. So we have x and 4x, which would give us 5x. And then minus 2 and plus 20, which would give us plus 18, is equal to 3x minus 9. If I want to solve that for x, I want to get the x's on the same side, so I'm going to subtract 3x from each side. And I'd get 2x plus 18 is equal to negative 9. Now I want to solve for x, so I've got to move the 2 and the 18. I'm going to move the 18 first by subtracting it from each side. So I get 2x is equal to negative 27, and then we're going to divide each side by 2, and we get x is equal to negative 27 over 2, which is the same thing as negative 13 and a half. And that is my answer. Totally okay to get a fraction or a decimal as an answer. All right, let's go through the last example, which is x squared minus 5x minus 6 over x squared minus x minus 1 over x minus 1 is equal to 1. So first thing I'm going to do is make this one a fraction, so it's 1 over 1. Then we're going to get common denominators by looking at the most complicated one, which is the x squared minus x. So x squared minus x, I can actually factor to be x times x minus 1. So the middle fraction, the x minus 1 fraction, really only needs an x. So I'm going to multiply the top by x and the bottom by x. And then the last fraction, which is 1 over 1, needs all of it. So I'm going to multiply it by x times x minus 1 on top and on bottom. All right, so what we'd be left with is the first fraction would stay the same, x squared minus 5x minus 6 over, I'm gonna put it in factor form, x minus 1, or x times x minus 1, minus 1 times x is x over x times x minus 1 equals x times x minus 1 over x times x minus 1. All right, and then now that the denominators are all the same, we can cancel them out. And we're just left with the top. So x squared minus 5x minus 6 minus x is equal to, now I'm going to FOIL it. I know it's kind of confusing that I go back from factoring to FOILing, but when we're solving equations like this, it's easier if you don't have any parentheses, so you'd get x squared minus x. All right, so now we want to solve this. The first thing I'm going to do is combine like terms on the left, which are just the minus 5x and the minus x, which would give us x squared minus 6x minus 6 is equal to x squared minus x. Now I'm going to try, because I have an x squared and x, I'm going to try and get everything on one side. I'm going to subtract x squared from each side. But notice you cancel out the x squareds on this side, and it also cancels out on this side because it's x squared minus x squared on both sides. So now I'm just left with negative 6x minus 6 is equal to negative x. I want to get the x's on the same side, so I'm going to add 6x to each side. The 6x's cancel out over here. I'm just left with negative 6 is equal to negative x plus 6x gives me 5x. Then I can divide each side by 5, and I end up with the x is equal to negative 6 over 5, which is negative 1.2. And that is my answer. And this is how we solve rational equations.